Number 6 is an application of in-center and circumcenter problem. So mostly in-center, but there's some application to the circumcenter here. To ship cylindrical objects such as plans, posters, and blueprints, FedEx supplies packages in the shape of an equilateral triangular prism. So sketch the triangular base of the prism. So if I'm just going to be looking at the triangular base, if you notice here, it's a 15 by 15 by 15, so it's an equilateral triangle, right? So all sides are going to be equal. And then the circular outline of a rolled up blueprint of the largest diameter that can be shipped. So that's the one that's going to touch each of the sides, right? So that's as big as it can get. Notice that this is pretty smart. It's a use of inscribing like a circle inside a triangle in order to get something circular mailed, but have these corners that protect it. And not have to build something circular itself, which can be sometimes a pain. So now that's just A. There's the sketch, right? B says, what is the diameter of the rolled up blueprint in part A? So here's where we have to start applying the properties. Like, how did we get this circle inscribed in here? Now remember to get, and look at these. This is like each side is going to be 15 centimeters, okay? So to get the circle inscribed, remember, you use angle bisectors. So angle bisectors, so all the angle bisectors are going to meet right here at the center. So that's how you get the in-center, but then remember to get the radius of the circle, you draw a side that's perpendicular. You draw perpendicular segments to the sides, right? Now, the special thing about an equilateral triangle is that the in-center happens at the same side as the circumcenter, where you have these perpendicular bisectors, and they're meeting at the in-center, and then you draw it to the vertices. So we actually could put a circle around this too. We don't need to. But we're going to use that information that this special case of equilateral triangle, this in-center's side, it doesn't just hit perpendicular, but it actually bisects the sides, which is that doesn't happen all the time, right? But it's special for the equilateral triangle that it does. So we know that not only is this length 15, but we know that from here to here, right? From here to here, this is 7.5 centimeters. 7.5 centimeters. And the other thing that we know then is that this right here, remember we created this line to be an angle bisector. With an equilateral triangle, this angle is 60 degrees. So if we created angle bisectors, then this angle is 30 degrees right here, right? So I've now got a right triangle where I know a lot of information. So the great thing is when you can create a right triangle, when you know, oh, I've got a right triangle, there's all kinds of now tools that you have. You could use Pythagorean theorem for them. You can use tangent, sine, cosine. Those are all things that you can use. And I have enough information right here. I have an angle. I want to know the opposite. I want to know that radius. This is the radius of the circle. I want to know the opposite, but I know the adjacent. So I need to find the thing. The formula that combines opposite and adjacent is tangent. So I know if I use the tangent, I'm going to find how long this is, and that's going to give me the radius. They want the diameter, so I'll just double it. So tangent of 30 degrees equals opposite, so that's the radius, over adjacent, 7.5. So I go to my calculator, and I make sure that it is on degree mode, because I'm working in degrees here. I don't think that worked. Okay, and then I say, okay, tangent of 30 equals 0.5774, and that's still equal to r over 7.5. And then if I cross multiply, right, 1 times r is just r, and this times this is 4.33. So r equals 4.33. So now I know that the radius is 4.33. The question's asking about the diameter though, so I multiply by 2. That's 8.33. 1.66 centimeters. So the big takeaway from this is that you want to use your principles of geometry to sort of figure out where those right triangles are, and then use the ideas of Pythagorean theorem or trig to solve for those sides. Anytime you can break things down into right triangles, you have a lot of tools to find the lengths.